Hello, I'm Chris Athanas. I'm a KMP developer. Tech support's coming out Tuesday to get that thing shut down. Finally, I can't shut it down. I don't have the right tools. So. Anyway, today I'm going to be talking about remote process calls, RPCs. Remote process calls. It's a new library that's coming from JetBrains. It's all based on Kotlin from the ground up. This is a demo of the app I'm going to be demoing for using RPC. It's like, what is RPC? Okay, let me switch over to that. Hold on. Okay, so this little video, I'm going to show the first part of it. It's talking about gRPC, which is the same exact idea, except it's based in Kotlin, and it's all Kotlin-idiomatic, and it removes a couple friction layers. But it's basically this.
APIs between my backends. And after this video, neither will you. Every time you use a REST API, you are actually invoking a remote procedure call to the other server. You're calling some function on it. Using REST instead of gRPC brings a lot of issues with performance, readability, and maintainability. You have definitely seen this before. Serializing data to JSON, building a HTTP request, waiting for the server's response, parsing into JSON, validating the format, and finally executing business logic. Everything can easily contain bugs. That's where gRPC comes in with two basic primitives: the protobuf message, specifying your payloads, and the service definition, or your endpoints. Let's convert the payload.
So this library that's coming from Kotlin,
specifying your payloads, and the service definition.
You just don't find the service. It does all this other stuff under the hood, which is pretty amazing.
Or your endpoints. Let's convert the payloads first. We create one protobuf for the request.
Okay, so we're not doing it that way. We're doing it a different way. We're doing it in a different way. And here it is, right here. This. Let's look at this.
Hello everybody, thank you for coming. My name is Sysoev. I'm software developer at JetBrains, and today I'm happy to present to you our new library from KotlinX family that is called KotlinX RPC. So we don't have much time, let's get it going. So here's our plan for today. I will do a little introduction, answering the questions of why and what and how it all happened there, what is the idea. And we will go through the basic stuff, the easiest setup for your application with the RPC services. We'll go through the features, so the main features of our library, and we will try to look into the future. So let's start with the introduction by answering the question of what is actually RPC. So RPC is standing for remote procedure call. Let's have a quick example. So imagine you have two machines, you have two services on them, and you want to call some function that will calculate bonuses for your application for a cafe app, for example. So your users make orders, and you want to calculate bonuses based on that orders. But it so happens that the bonus system that can calculate it is on another service. So you decided to move it to another service. But you still want to call a function. So in that case, you just make an RPC request. You say, I want to execute the calculate bonuses function with an order argument, and you execute this function on another machine and return a response. That's the basic idea for the RPC. And in terms of Kotlin, it can ideally look something like this. So again, we have our coffee service, we have our bonus service, they can communicate, and there is our coffee service class. That has a bonus system there, and we just call this function. It's regular Kotlin code, and we don't know anything right here about how.
It's just regular Kotlin code. So that's the thing that's kind of special about this particular flavor of RPC, is you're just writing Kotlin, which is, I was blown away. I was like, no, that can't be. That's not. That's like, oh.
How it all connected in terms of services. But it's still easy to write, and it is easy to read. And we want to preserve this easiness and conciseness. So in this case, we can call the bonus system our RPC service. And let's say we want to define it in the common code, because we use multiplatform, we have this amazing technology. We can define our RPC service in the common code. We mark it with some arbitrary RPC interface just to make sure we know that it is an RPC service, and we define this function that we want to use there.
Right, so it's just you're just defining an interface in the common code between your front end, whatever it is, whatever your target is, iOS, Android, web. You know, I'm going to show desktop. I'm going to show iOS web. I'm going to show iOS, desktop, and Android in this example. But it's just Kotlin code. So this, because you put it in the common area, all the multi-platform stuff gets to look at the interface, and it just gets code generated when you build those applications, as well as the server. You look at the same interface, it actually generates this code as well. That's the special sauce.
Mark it with some arbitrary RPC interface just to make sure we know that it is an RPC service, and we define this function that we want to use there. And on the bonus service, we ideally want just to implement this interface. So we can accrue bonuses in this calculate bonuses function and be done with it. So that's all the logic and all the things that we ideally would have to deal with RPC services here. And now, using this knowledge, we wanted to make a library that can do this easy setup for you, that you can work with, and you can do it multi-platform. So yeah, with no complicated stuff and no complicated setups. And for that, I'm happy to present you the KotlinX RPC library, and I will show you how we can do it now using that library. So We will start with a quick setup in our Gradle configurations because it is really important here. So yeah, of course, we have our Kotlin plugin.
Okay, I'm going to go through all this part.
Correctly, the app, and it's
Not that
let's get back to the library. Compiler plugins will know that it is your RPC plugin. They will generate the code for you needed in order to everything to work properly. And also, you may notice that we use an arbitrary data class here to pass as an argument. And the only thing that is required from you as a user to define here is just to mark it as a serializable with the annotation from KotlinX serialization. And the serialization process will be handled by the library smoothly for you.
Right, so using KotlinX serialization, which is standard in the front and back. So that takes away this whole other thing. But which serialization library should we use? Which one are where are the incompatibilities? And which one accepts? It's like, no, one library, front and back.
There, right. Now, that is our client code that we saw before, that we imagined how our library can look. And actually, with the KotlinX RPC, it looks pretty much the same. So the only thing that changes here is that we add a special entity that is called RPC client. So this RPC client, I will talk about it a little bit later. But now, what's important is that RPC client entity allows us to call this special method that's called withService. You provide it the type argument of your service, and you get a generated instance to use. So this instance is called service tab in the RPC terminology, and you can just use it as a regular implementation of this interface. You can call the calculate bonuses function on it, and it will.
Right. So this is now just like any other class or any other object in Kotlin. You can write functions, call functions on it as if it was local. Pretty amazing.
It will make the RPC request, and that's just it. It is a really simple setup here. Same for the server. So this is the code that we imagined our ideal RPC library can have. And we just here implementing the bonus system interface, right? And in KotlinX, you just need to add the coroutine context parameter that will handle lifetimes of your services, because we use coroutines extensively to handle lifetimes of the requests, services, and so on. So that's just the code for your RPC implementation of your RPC service, right? And that's the code how you use it. So here you can see that we add the entity that is called RPC server, similarly to what we had on the client. So we had RPC client there, here we have RPC server, sorry, and they can communicate with each other somehow. We will talk about how just in a bit. But important thing here, we just register our service, we provide it with a type argument, we provide it with a builder function that also uses the coroutine context, and that is how you connect your services between the network.
That's it. Okay, so I'll let you watch the rest of that. I'll give a link in the deedly-do. Here's a demo of the app. So all three apps, this is the Android, this is iPhone, this is the desktop version, and the log out here is the actual server running locally. It does a couple different things. I've set it up here, so it just gets random news articles if there's no topic. But if you give it a topic like reading, it has to be capital letters, reading. It'll just give you topics, the news on that one, and they're all independent. There is no service tokens. There's nothing like that happening at all, which I'll show you in a second. It's basically where's the app here? Here's the KTOR app that's running this thing, and here's the news service right here, which is that is just defined as an interface, and the impl is right here, and it's basically has these two functions that are responding to as if it was, this is the server code. This is the KTOR server. There's no HTTP request. There's none of that. It's just call in, and it's all happening using WebSockets underneath. And he may actually swap it out for protobufs. They're talking about that. I'm sure they will. And the reason why it's not, I don't have the web version of it is they're still working on that. This is 0.1 version. And it's already amazing. This could be my go-to for future backends. It's for that need to have streaming back and forth. So all these things are streaming in, right? So let's do this one. It's like, let's do this one here. Science. So those are streaming results, right? They're not being passed immediately. They're streaming in on a flow. And here's magic. Let's search for magic. Okay. Same thing. So what happens if the server shuts down? Oh, let's try it. Okay, let's just reboot the server. Here we go. And because it's streaming, there's a constant connection to the server. And we know immediately, because we're pinging the server, when it goes down and when it comes back up. Oh, and you can just keep going like nothing ever happened? Yeah, sure, why not? No, there's no, this is it. This is it right here. This is the program right here. That's the server. And on the front end, okay, now we can close some of this down and make my performance of my machine run a little faster, because it's kind of a dog when all this stuff's open. Let's close that one down. and look at the. So this is the server side. This is it. This is here right here. Here's the the interface that you define between the two platforms, and and here's the ping. The result just returns Pong. Okay, return Pong. Where's the encoding to JSON? Nope, none of that stuff. It handles all that stuff for you. And then here is the compose side. Let's go here. Hold on a second. Let me get this all ready for you. All right, so here's the app. Here's the compose app, and you have the different entry points here, of course, for for your desktop, for your iOS app, whatever. They're really super. These are super simple. There's really not much here, right? There's just really not much here in these things. Here's the app, which is one big compose app, and I have the state for the application all up here as mutable state. And here we have the launch. We're launching connect to the RPC server. Let me go ahead and close this down here. Make it super simple here. So here we are, this is where we actually open up, start the connection to the RPC server. Right here, service equals setup RPC. What does setup RPC do? What does that do? It just goes in and goes to your HTTP client, right, which is right here. It sets that up, and then it adds this .rpc onto it, and then it does this config here for which serialization library you want to use. You want to use JSON, and then for the timeout, you can set the timeouts for all the stuff on how the RPC is going to work before it starts complaining. And then so here's it connected, and this is the thing that loops around and makes sure it stays connected. There's no special library, everything. It just if it gets unconnected, it throws an error, drops out of that loop, and then comes back in here and starts to try to reconnect it again. And once it's reconnected, it pings it until it stops. And that gets try catch thing, just goes again in a loop. Boom. There's your retry back off from the client side, right? And then once the service is connected, you can then do the basic greeting call, which is just calls right here. It just calls that service right here, service.hello. What's that? It's just this right here. It's just this right here. So where is it implemented? Let's go look. It's over here on right here. That's the function right there. So you're just basically calling that function. There's no protobuf stuff, nothing. You don't set any of that stuff up. You just do the interface, and the plugin, and it does everything else. And it's all written in Kotlin, and you do everything you do even for the flows. That flow. See, it's extending. It's not just returning a string. You can return a flow. So it's streaming back and forth, data back and forth. So it makes games super easy, as if it was just local, right? And instead, normally you send pass in an ID, right? User ID, and you do confirmation on that. And there may be a way to automate that or do that. So I haven't looked into it yet. I'm just like, holy crap, this makes writing front and back applications super easy. Like the server code and the back end and the front end is in the same code base. So it gets real difficult to get them out of sync because it's in the same code base, and everyone knows where everything's at. Everyone that's in this code base already knows Kotlin, so they can just go, oh, it's just a flow. Oh, I already know how that works. None of this, you got to learn a whole new technology and make sure it's like, no, it's going to be everywhere. This is going to be, when I first got into learning about web development, I was like, I thought it would just be something like this. They would go, okay, you definitely want to abstract that serialization away and the communication away, and let me make sure it's going to be two-way. We're going to want that, right? I thought it was going to be something like this, where you'd have, here's the back-end code. Yes, you have to set it up there for multiple users. Right now this doesn't really care about users. Just whoever asks gets it, right? And instead of doing the serialization and then encoding it into the data model for the data structure, and then running on that, and then sending that, and then sending that over the wire, and then deserialization, and that whole mess, which is fraught with danger and hassle and just really, I mean, it has a use case. Don't get me wrong; it definitely runs the web, but wouldn't it be easier if it was just like this? It's like, oh, you're calling a function back there, okay. I mean, and you can't step through it all the way from front to back yet. They are talking about that, and they will have the JavaScript target for the WASM target soon. So here's how you get the article stream. You just refresh this thing, and it goes and just does a call, subscribe to news, and then collect on that flow like everything else. You just collect on a flow. Wow. And then here's the UI. It's super simple. You know, it's just a column, and it's got here's the greeting, and then it gets the text from the greeting after it. You know, where it got it here. You can actually might even be able to do the call there. I don't know if you want to do a remember block. Well, better do it. Probably better do it a launch effect block. And it doesn't. I mean, it's just a function call. It's just a function call. There's nothing special about it. You could call it from there every time it does a refresh. I mean, if you really want to, that's probably being efficient. And then here's the error. So when the error state changes from when this thing gets the ping stops, you know, they make such a big deal about this exponential back off, and it's like, dude, it is. Like, and I wrote it in just a few minutes. I was like, okay, how do you reconnect this thing? Because that's not in the demo. But I was like, okay, how does this work? Anyway, so I'm going to keep, I'm going to get the links to all this in the daily do and links to this right here. The only gotcha is when you set this up. Hold on, let me get this thing. Let me show you the file. So on Android, you have to go to this network security config, which makes it so it allows you to run locally and without using clear text. You have to use your local, whatever your machine IP address, you have to fill that in there, right? So that's one little gotcha. And if you're doing a commercial where you're not going to do clear text, so it doesn't matter. So this will be moot. This is only for local debug when you're doing development. And if you don't know what that means, just look up here what that's going on there. It's got a little note there for you. And where's it? One more thing. Okay, so here is your dev server host. This is going to be your local IP address where you're going to be running this application, and you run it from these menus here. And I'm going to try and keep it local, but you can run the Compose app, which is Android, so it looks like a little Android logo, and you can run that from the IntelliJ IDE. You can run the desktop from IntelliJ. You actually have to run it from the IntelliJ IDE, but and the server can be run from here. But the iOS app, you have to go to Android Studio or run it from there, or from Xcode. You know, either one. So that's the only one. For some reason, it doesn't work for me. I'm like, okay, whatever. Now this new fleet, I tried it once, but it froze up on me, crashed twice. So I think it was in too early. I'll try it again in a few weeks, maybe. All right, so that's the network security config, blah blah blah. Let me see one more thing. Okay, so for the application config for the server right here, you do want to change the host from this 127.0.0.1, which doesn't seem to work for me, to your local IP address. And the way you find your local IP address is you go over here, your system settings, and you go to your network card, and you look for an IP address, and that's it. That's all you gotta do there. Let me see if there's anything else. Well, I guess that's about it. You need to know for right now, and you can experiment with the current set of tooling. And it's like, I'm just like really impressed. Really impressed. And JetBrains is really kind of kicking ass lately with the KMP, and then having multiple targets. And I know the iOS devs are going to fight tooth and nail against it. So there's a good opportunity here to take some of their pie away because they're just unwilling to look at this technology because it's not coming from Apple. You know, it's like, okay, I get it. I know you've been burned before, but I mean, JetBrains has really got their shit together. I don't know. I don't know how you feel about it. I'm really enjoying it. And this is like a dream come true. I mean, I had, man, you know, I've already made my statement. Okay, I'll talk to you later. Bye.